Hello and welcome to our fourth maths lesson within our bridging activities, and this lesson is called Frogs and Toads. Today's lesson is all about problem solving, and we're going to develop our problem solving skills by applying logical thinking. You're going to find a rule that can be applied to solve a problem, and you're going to evaluate that rule and see how it is affected by different constraints. And we'll talk about this word constraints as we go through the lesson. So here is your starting problem. You have a man, a fox, a chicken, and some grain. The man must get the fox, the chicken, and the grain or the corn across the river. He has a rowboat, and it can only carry him and one other thing. If the fox and the chicken are left together, the fox will eat the chicken. And if the chicken and the corn are left together, the chicken will eat the corn. How does the man do it? Spend some time now trying to figure out a solution to this problem. If you get really stuck, on the next slide, I will give you a hint. So here's a hint to the problem. What if the man took something back with him across the river? Ready for the solution? Okay, here we go. So first of all, the man and the chicken cross the river. That means that the fox and the corn are safe because the fox won't eat the corn. The man then goes back across the river, leaving the chicken on its own. The man then takes the fox across the river, but he can't leave the fox with the chicken on its own because the fox would eat the chicken. So he takes the chicken back to where he started, leaving the fox on his own. He then leaves the chicken on its own and takes the grain over. He then leaves the grain with the fox and goes back for the chicken. He then picks up the chicken and goes back across the river one last time. And now everyone has made it across safely and all in one piece. Phew! Now that starting problem was there to get you thinking about problem solving and the logical skills required within it. We're going to now look at our main problem called the frog and toad problem. And to explain this, I'd like you to watch the following video clip by clicking on the square, or if that doesn't work, click on the link. Okay, so here are the rules. We're going to think about this word constraint. Constraint means when it's like a rule that you have to follow, and it means that you can't work outside of the constraints. You have to take those into account. This is really important when you're problem solving. The first constraint is you have to slide onto an empty adjacent lily pad. For example, the frog can move one place across to the next lily pad. Constraint 2 is that a frog can jump over one of the other frogs or toads onto an empty lily pad, but he can only jump over one as shown. And constraint 3 is that you can't move back a space, only forwards. So those are the 3 constraints to this problem. To set out your results of this problem, use the table that you can see on the screen. And we're going to start with one frog and one toad, or one red and one blue, and so on. And there's a link that you'll be able to see which will take you to an interactive version of this problem, which you can use as we go through the rest of the lesson. So you're going to start with one frog and one toad, or one red and one blue on the interactive version. What is the fewest number of moves needed to swap them over? Now try to swap over 2 frogs and 2 toads. What is the fewest number of moves needed to swap them over this time? Keep going and try with 3 frogs and 3 toads. What's the fewest number of moves needed now? You should be putting your results in your table. Try to see if there's a pattern within your results, and can you use that pattern to predict the number of moves needed for 4 frogs and 4 toads. Now test your prediction to see if you were right. So here are the answers. You can see in red 3, 8, 15, 24. Did you notice a pattern in your answers? If you look carefully, the difference between the two numbers from the previous term increases by 2 each time. So 3 to 8 is 5, 8 to 15 is 7, 15 to 24 is 9. It's increasing by 2 each time. Okay, there's lots of ways that in which you can extend and explore this problem further. Could you predict and check how many moves it would take for 10 frogs and 10 toads? Go back down to the beginning and break down your results into the number of slides, so moving from one to the next, and the number of jumps where you've hopped over each of the frogs or toads. Can you spot a number in the spot a pattern in the number of jumps and slides? Can you generalize? So basically, can you come up with a rule for the number of jumps and slides? And what about if you change the number of frogs and toads, e.g. trying with 1 frog and 2 toads, or with 3 frogs and 2 toads? Could you mix it up and see what happens when you have different numbers? Click on the link on the screen and this will take you to a website that has an interactive version of this problem. Okay, so let's go back to our objectives from today. We aim to develop our problem-solving skills by applying logical thinking. We were hoping to find rules to apply to solve a particular problem. We were testing or evaluating those rules when they are affected by different constraints. So let's reflect on what you've learnt today, and you can use these questions in your Bridging Activities booklet. So first of all, how did you develop your method to find the best or the most efficient solution? What happened when you altered the number of frogs and toads? How did this affect your results? And is there a rule to follow to find the least number of moves based on the number of frogs and toads? Have a think about these questions and write your answers in your booklet.